And next we have Joan Schaffer, our math specialist at the elementary level, and she's going to be giving us a little presentation on our elementary math program.
So it was a surprise when Nancy asked me to come and speak with you, but it really is my pleasure to do so. I'm pretty passionate about the work of elementary mathematics, and I love the opportunity to come and share with you some of the challenges that we have and how we're trying to meet them. So I start by saying that elementary mathematics is not elementary at all. And I think I'm going to prove that to you tonight. A lot of people say, oh, it's just arithmetic. And when I went to school, a lot of it actually was just arithmetic. But that's just not the case now. So I want to start, this is a quote taken directly from our state frameworks. It's the first guiding principle. The mathematical ideas should be explored in ways that stimulate curiosity, create enjoyment of mathematics, and develop depth of understanding. It's sort of my guiding principle, and I just wanted to be aware. So I want to start by just saying that we are in a landscape of very changing expectations where it comes to math. And just to give you a few examples of that. Okay. When I went to school, we focused mostly on procedural knowledge. How do you add, subtract, multiply, and divide? But now we are really working with standards that are very conceptual. So if you take a look at the problem on the right, I think most of us could do that without any problem. But if you take a look at the problem on the left, using these digits make two 3-digit numbers that when added together have a sum between 800 and 1,000. I think any of us would have to think a little bit about that. And also we'd have to know something about place value in numbers. We'd have to know something about estimation. So it's much more of a complex task than arithmetic. So this is a sample item from an old math test. This is how it used to be very straightforward. A bus holds 65 people. How many people do 8 buses hold? You perform an operation, hopefully the right one, and you know. So let's take a look at, this is actually on the park website. This is a sample, and you have this problem in your packet. The last page has 2 park problems, one on each side, and if we have a chance, if we have enough time, maybe we'll play with these. But here we have 3 classes, and those are listed in the table that are going on a field trip. The table shows the number of people in each class. They can choose buses, vans, and cars. And the student, and it tells how many seats each vehicle has. And the student has to choose which 3 combinations can be used to take all 3 classes on the field trip. Okay, so we have a multi-step problem here. We have a very deep level of analysis of each of the possible answers. And we are not just trying to choose one answer. We have to find 3 out of that group. So,
what grade, Joan, for something like this?
3rd.
Wow.
This is 3rd grade. I was going to ask you to guess.
Oh, I'm sorry.
That's okay.
I'm blowing up your spot. Oh, I'm sorry.
But, yeah, I mean, if it was a 4-part multiple choice, typical multiple choice, the child has 25% chance of choosing the right answer. But the chances of choosing the 3 correct answers are just a little bit less. So here's a 4th grade sample. The side of a square is 20 feet. What's the area of the square? Again, very straightforward. Here's a perimeter question. Now take a look at this one. The perimeter of the rectangular state park is shown as 42 miles. Okay, so the ranger estimates that there are 9 deer in each square mile of the park. If this estimate is correct, how many total deer are in the park? Explain your answer using numbers, symbols, and words. Okay, so what do you notice about that? Any noticings about that question?
The length of the park is missing.
Pardon?
You need to figure out the length of the park.
You have to. Okay, so you have to start by figuring out the length.
I feel like I'm back in
We're kind of need to answer all of these.
Yeah.
So what about the answer? It says if the you're supposed to estimate. First of all, it doesn't ask for an exact answer, it asks for an estimate. How many total deer are in the park? Explain your answer using numbers, symbols, and words. Okay, so there's
By symbols? I'm not really understanding.
Well,
Yeah.
symbols might be addition, subtraction, multiplication, division, greater than, less than, those kind, mathematical symbols and words. So just wanted to start out by showing you how the expectations are changing. That's 4th grade. So now I'd like to show you I'd like to get you into our new state standards and to show you a few of the standards so that you understand how specific they are and how and the kinds of details they have. There are 2 types of math standards. They're the content standards, which tells you what you're going to teach. When are you going to teach equivalent fractions, and when are you going to teach area and perimeter, okay? Then there's the mathematical practices, and the mathematical practices talk about how we expect students to work with mathematics. So let's just take a look. This is a content standard. The K stands for kindergarten. The OA stands for operations and algebraic thinking. So our kindergartners are working with operations and they're working with algebraic thinking. So this comes under a subheading that has to do with understanding addition as putting together and adding to, and understanding subtraction as taking apart and taking from. So the specific standard is, for any number 1 to 9, find the number that makes 10 when added to the given number, e.g. by using objects or drawings, and record the answer with a drawing or equation. This is a kindergarten standard. So in other words, if I say 4, you've got to come up with what? 6, right? Okay. So I just wanted you to notice that this is algebra. You're finding a missing value, okay, in a number. It's not saying what is 3 plus 2. It's very different. This is a different kind of thinking. So let's look at another standard.
The language.
And what would be the drawing or the equation with that?
So a child might write.
How would they know it?
A child might write 4.
No, they don't. That's not written to a kindergartner. That's a standard. So a teacher needs to be able to assess.
This is
the teacher.
Demonstrate. This is the standards that are written for the teachers to tell them what they're supposed to teach in kindergarten. So, so a child might just draw the 4, and then might draw 6 more. So that might be how they represent it. They might write 4 plus 6 equals 10, depending on the child's level. I'm just wondering, oh, there we go. Okay, so here's a 3rd grade content standard. Also operations and algebraic thinking. And this one involves multiplication and division. And again, the underlining is my underlining. It's not in the standard, but it's the piece I want you to think about. Use multiplication and division within 100 to solve word problems in situations involving equal groups, arrays, and measurement quantities, e.g. by using drawings and equations with a symbol for the unknown number to represent the problem.
What symbol do they use? Do they use X and Y?
Letter variables are introduced in 3rd grade.
Wow.
Our kindergarten, 1st, and 2nd graders use what we call a mystery box. They use an empty box to note an unknown value. And we introduce the letters in 3rd grade. So again, you can see that. And also, what else do you notice that I've underlined? Besides the symbol for the unknown number, the fact that they have to produce, they not only have to solve the word problem, but they have to produce a drawing that represents it or an equation. Okay, so an answer is not enough. I think that's the piece I'm trying to. Okay, one more. Numbers and operations, fractions. This is 4th grade. Okay, and the part I underlined is right up front. This has to do with fraction equivalence and ordering. Explain why a fraction, a over b, is equivalent to a fraction n times a over n times b by using visual fraction models with attention to how the numbers and sizes of the parts differ, even though the 2 fractions themselves are the same size. Use this principle to recognize and generate equivalent fractions. So, what do you notice? It says explain. You have to explain. It's not that they're asking you just to generate equivalent fractions. They're asking you to explain why it works. Why when you multiply the numerator and denominator by the same number, why does it generate? And to be able to show it with a model. So these are our content standards. Very specific. They tell us not only what the child needs to be able to do, but how they need to show that they understand it. Okay, standard for math practices. These describe the varieties of expertise that mathematics educators should seek to develop in their students. So this is not what the teachers are supposed to be doing, it's what they're supposed to get the students to do. I have given you the second page of your handout. You have a list of all of these math practices, sort of in a friendly, now each one of these has a lengthy paragraph in the standards. They go into great detail to describe them. But briefly, make sense of problems and persevere in solving them. So the idea is that you shouldn't read a problem and immediately know the answer. They're setting up the students to understand that problems can be complex, and you actually shouldn't jump into solving them. You should take some time and try to understand what the situation is before you attempt to solve it. And that it might not be easy. You may just have to really work at it. Okay, you may have to struggle a little bit. That's okay. Then the second one, to reason abstractly and quantitatively, to really be able to reason. The third one, construct viable arguments and critique the reasoning of others. So mathematics is about debate and talking, sharing, how you go about this. I'm sure that you've probably seen this in class. Presenting your solutions and listening to other people, so present theirs. So going on to number 4, model with mathematics. I'm going to be showing you a bunch of models using tools, attend to precision. Obviously, we do want to get answers, and sometimes they do have to be exact answers. And attending to precision is also this awareness of what you're doing. And so that when you produce an answer that has absolutely no reason, that's totally unreasonable, that you're aware that this can't be right. Look for and make use of structure is one of my favorites. It's really trying to understand that there are things you can depend on in mathematics, that it isn't hocus pocus, that there's a logical sequence, that there's a code that has a lot of repetition, and the last math practice, seeing that there's regularity and repeated reasoning. So these things are your how we learn math. So now I want to talk a little bit about how we try to meet these standards. With right now our primary resource is Math Expressions Program. And actually, I was looking back at the history, and we have been in full implementation of this program for 4 years now. And then the year before that, we piloted 1 grade level. So our current 4th graders have had this program since 1st grade. When we chose this program, we had a committee. We looked at 5 programs. Nancy actually chaired the committee. And we were very impressed with certain aspects of this program that I'm going to show you now. The standards, the Massachusetts version of the Common Core Standards came out in 2011. And our first year of full implementation, I believe, was, I wrote it down, it was, well, it was 2011. The year before that, we piloted 1 grade level. And what was really kind of fortuitous is mathematically, even though every content area wasn't aligned to the new frameworks or to the new Common Core, the mathematics in the program was very consistent with the approach, with the structures that were in the Common Core. So in 2011, we were already at it. We didn't have to play catch up. I am in touch with school districts that are looking for programs right now, and and this is a program that they're considering, but we were there. So some of the structures that support the content standards and the mathematical practices that are in the Math Expressions Program. The first one is an emphasis on algebraic thinking. The second is the use of visual drawings and models. The third is a plethora of complex problem solving. And the fourth is an emphasis on communication, oral communication and written communication, of it being, explaining mathematical ideas and explaining problem solutions. So I mentioned the mystery box. So there's our mystery box, and that is very typical of first grade. This is probably very typical of second grade. Moving on to third grade, and then substituting with a letter variable. We want students to understand that the equal sign is not an announcement that an answer is coming. It actually means that whatever you have on the right side is going to be equivalent to what's on the left side. And so the students have problems like this. And then the last one I pulled right out of a fourth grade book. So that is a equation that they have to solve. Okay, this is our puzzled penguin. Poor puzzled penguin is so confused. He really doesn't get math very well. And the kids have to straighten him out all the time. This is from first grade. So puzzled penguin has this problem, 2 plus something is 8. And poor puzzled penguin just looks at that 2 and that 8 and throws the 10 into the mystery box. And we have to help puzzled penguin. And so this, in that box, using drawings or using words, our first graders would try to explain to puzzled penguin why that doesn't work, and then they would do it the right way. So the puzzle penguin is throughout the program, and I just want to say that I was doing the PARC test in March with a special needs student, and the PARC is full of questions, especially the performance-based assessment, where they show a wrong solution, and the children have to say what's wrong with it and explain how to do it the right way. So our puzzled penguin is working on that. So this is just an example of a PARC third grade fluency. Again, click on all the equations that are true. They're not telling you how many. There's a lot of analysis. There's a lot of work that has to be done. It's so tempting to just mark a few of those boxes. There's also this habit of mind, like how do we get kids to do all the work and actually figure out and which equations are balanced or not. That's a challenge. So now I'd like to move on to the second thing I mentioned about the program, and that is the drawings and the visual representations. So these are from, I think, kindergarten. And if you look at the number line on the top, I don't know if you can see, but there's little red dots that represent the numbers. And as soon as you get to 5, they start a second row. And this visual representation of 6 through 10 is kind of filling in that 2 by 5 matrix is something that really the kids start to internalize. And they actually have a poem. If you look at where the fingers are, it says 5 in a row and 3 below. They have like a poem. It's 5 crows in a row and 3 below, how many crows? And they really start, and plus they're learning those math facts. They're learning all the 5 plus facts. And the stair steps are another visual tool we use in kindergarten and first grade. If you look at the 8 with the circles next to it, they're representing 8. Later we use representations like that for doing something like adding 8 plus 8. Instead of starting, young children tend to 1, 2, 3, 4, 5, 6, 7, 8, and then they count again, 9, 10, 11, 12. We say, okay, you already have 8, so then you can count on and you can write the 8 and do circles. So this is a very famous part of the Math Expressions program, the Math Mountain. The Math Mountain starts in kindergarten. It's a model for helping children understand the relationship between addition and subtraction. So the total goes on the top, and the 2 parts go below. In kindergarten, the children learn a story about all these rocks on top of the mountain, and some of them fall down one side, and some of them fall down the other side. And, they started with 15 at the top, but some of them went down the right, and some of them went down the left. And in kindergarten and also in first grade, a lot of times the kids draw what they call the tiny tumblers down the side. So they use this, it's a graphic organizer that they use when they're solving word problems to actually think about the numbers that are in the problem, you know, and where they go. Do I have a total, or am I looking for the total? Because when I went to school, usually I got a whole page of addition problems, and I didn't even have to read the problems. It said addition problems, so I just added the numbers. But the problems that these kids have, they're all different. Some of them might be addition, some of them might be addition with an unknown part, with an unknown add-end. So there were 9 children playing in the park. Some more children came. Now there are 15 children playing. How many children came to the park? So hopefully the child's going to realize that that 15 is the total, and they write an equation, 9 plus mystery box equals 15, and then they might solve it by subtracting 15 take away 9. But that first equation is something we call a situation equation, because it mirrors the situation. It goes in the same order. First there were 9 children, and then 9 goes first. Then some came, and our first graders kind of know that some usually means we don't know what that number is. So this is a very useful model. It changes, in 3rd grade it becomes a break-apart drawing, but they can use it all the way through to 4th grade. This is a model that's used for multi-digit multiplication in 4th grade, for multiplying 67 times 43, where students are breaking the 67 into a 60 plus 7, and the 43 into a 40 plus 3, and they take it in parts. So it's this idea that you can break numbers apart, and you can perform smaller calculations, and then you can put those numbers together to get your total. I don't know if any of you ever learned how to multiply this way, but for a lot of children, it not only makes it meaningful for them, instead of just trying to memorize steps, but it also teaches them the distributive property, which is a hard property to learn. So just going back to my slide, we talked about the emphasis on algebra. We've talked about the visual drawings and the models. So I'm just going to do a little bit about complex problem solving. The program asks kids to solve problems using 4 steps. And the first step, we put a lot of emphasis on: understand the situation, restate the problem. So a lot of times we'll ask the children to say the problem in their own words, or to try to imagine themselves in the bowling alley or the ice cream store, wherever the problem takes place. Then the second step is to represent the situation with some kind of a drawing, or if they're comfortable, to go right to an equation. Whenever they write equations, we ask them to show in the equation where the unknown is. So they're going to have a mystery. Even if they know what goes in that box, they still write the box. So all of that before they actually solve it. So many kids want to go right to the answer. And this is really asking them to really think about it. And then the last step, to check and make sure the answer makes sense. That's a tough one. It's really hard to get kids to, they're done. So here's an example, 2nd grade, and they're using some of these models to solve some problems. The first one is a comparison problem. Amanda has 22 more colored pencils than Troy. Troy has 38 colored pencils. How many colored pencils does Amanda have? So these are called comparison bars. So the A stands for Amanda and the T stands for Troy. And we know that Amanda has more, so we give her a big bar. And we know that Troy has less, so he gets a little bar. And that circle, which is supposed to be like an oval, is the difference between the two. And in this problem, he knows the smaller amount, so that gets filled in. And that 22, what is that? Well, that's the difference. That's how many more. And then from there, he's able to write an equation and solve the problem. These kind of problems are really hard for kids to know whether to add or subtract. And again, the comparison bars, and that's right out of Singapore. I mean, it came from the Singapore math models the kids use. And then the second problem, you can see they're using a math mountain. The student's using a math mountain. and from there going to an equation. In this one, he's noted that the 14 is the unknown number. So that just gives you an idea of what it looks like when the kids are using these. The last thing I want to talk about is what we call math talk, and this is the communication part. So the NCTM is the National Council of Teachers of Mathematics Association. Students learn mathematics best when they're given opportunities to speak about the mathematics using the language of mathematics. There's a lot of heavy vocabulary in math, and they're words that kids don't use all the time, and this gives them a chance to rehearse them and to, oftentimes we'll put a list of words on the board when we're doing a math talk and encourage the kids to try to use those words. It helps our English language learners to hear it. So Math Practice 3, which you have on your math practices, is about constructing viable arguments and critiquing the reasoning of others. So this is working on that math practice. And what can we talk about? Well, we do sometimes computation, we'll just put up a computation problem and ask the kids to perform mental math, to just do it in their head. And then they explain how they did it, we write it all down, and the kids can see that there's more than one way to solve a problem. And they can also see that somebody else is using a much more efficient strategy than they are. So maybe the next time they're going to try that strategy. So it gets math out of this isolation that it's been in for years, where everybody's doing their own work all the time. The kids are learning from each other. We use math talk sometimes to unpack complex problems. Some problems just have so much information. It's very dense text. Math problems are very dense text. So sometimes the teacher will, do a math talk where, what do you know? What is the problem telling you? And you just spend a lot of time really modeling what we want the kids to do all by themselves. You can also work on specific vocabulary, and you can also share problem-solving strategies. So this didn't come out very well, but I did a number talk in a classroom, 15 minus 7. This is a second grade, and only about a third of my poster came out when I loaded it in here. But you can see that one child said, well, I know 7 plus 8 is 15, so 15 minus 7 has to be 8. And on the other side, you can see it's kind of cut off, but the child took the 7 and broke it into a 5 and a 2. Well, I know 15 take away 5 is 10, so 10 take away 2 more is 8. So you can see, you want me to go back over that? So I'm sorry that it got cut off, but that they sort of made a math mountain under the 7.
That's like, what an incredibly complex way for a child's brain to work to get to that. Like, you realize that everybody approaches it differently, uniquely.
Breaking it down.
Yeah.
Well, there have been analysis done that say that really, as adults, about 90% of the math we do is mental math. So it is nice to be able to work with numbers, and I'm sure you all have your own strategies for dealing with numbers. So that's a math talk. So the last part of this, I have those 2 problems there, and this is another. It's a protocol that came from the program. So let's say that they were doing that problem with the vans, with the van and the truck and the cars and the buses. The children would have some time to solve the problem, and then the teacher would, walk around and watch the kids solving the problem and choose some kids pointedly who they would like to have share with the class. And we try to create communities in the classroom where kids can take risks, where it's okay to make a mistake, where we all learn from mistakes. It's so important to do that. And so she might even choose somebody, And so the child will present their work, and and it's funny, the kids are learning language for this. Someone will say, well, and they get a chance to ask questions of the student who's presenting. Well, I respectfully disagree, or I respectfully agree, or why did you do it that way? Why did you break that 7 into a 5 and a 2. So they ask questions, and then the student can respond. So there's some really good conversation, and we love our dock cameras because they allow kids to just throw their work, and it gets projected, and everyone can see it. So it's really quite. So now I'm just back to these last 2 problems, and it's a big challenge. When the Common Core first came in 2011, did a number of professional development workshops where we traced strands vertically, K-5. We looked at the Math Expressions program, and we've had staff turnover since then. So there's always more professional development. Our elementary teachers teach many subjects. They're not just focused on math, which is where I try to help. But, so, any questions?
I guess, can you talk a little bit about your role in the elementary schools and kind of what support you lend and what your focus is?
Well, I try to do what's called embedded professional development. So I spend time in classrooms, and I do it differently. Sometimes I actually go in and I actually teach, and sometimes I go in and kind of co-teach. Sometimes I just go in and ask like a question to try to deepen the conversation. I do at times work with students when I'm in the classroom who might be struggling or else need a challenge. I do a lot of work with curriculum, because even though this program is, quote, aligned, no program is perfect. And sometimes we need to, I work with the assessment system. We try to keep really close data on the students for each unit. I look at that data. I talk with teachers about their data. I do professional development, meet with grade level teams. We preview units. We debrief units. Those are some of the activities that I do.
I have more, but if somebody else wants a turn. Okay. I'm curious, as a parent of an elementary student, what sort of supports would be most helpful to gain more success? I feel when I sit with my son and do this homework that I wasn't instructed these ways. Right. And I worry when I'm helping him that I may be undoing a lot of what he was learning in the classroom, because your default is how you were instructed as a child. So I'm wondering, and I don't want to continue to overburden the classroom teachers. I'm wondering if we can maybe try to find some way where it's accessible for parents, but it's not another additional burden on staff to try to find some way to meet in the middle to help us better support students, and try to learn these methods. And I don't know what your thoughts are on that.
Well, the program has parent letters. I don't know if you've seen those that come home.
Worksheets.
And they kind of give examples and explain it. We've done a number of different kinds of outreach to parents, but probably not enough. I find that if I have a program that's just for parents and it doesn't involve students, I get a low turnout.
Yeah.
I have tried having coffees in the morning after drop-off, or in the evening. The programs that we've had in the past, and we not this year, but we usually do get quite a bit of people, but it's not, and it's fun because the kids are doing math with their parents, and usually we make it, game-oriented, but I'm still not quite able to get the kind of message. Somebody had suggested to me that I make some videos, or I'd like to make more online resources. There is a website that goes with the program that we might be able to have parents access that would explain. I know that there are some resources there, but I also would be interested in in working with the PTO if they have ideas on how this could better be done.
We're trying to figure out what that volunteer structure should look like, and I think that a big part of that would be some sort of tutoring or support and that kind of interaction between parents, because what we're again, it's this. I agree. I was very suspicious of Common Core because it looks like an alien language to us. When you break it down, it does make more sense. It does, I have a really passing friendship with because I didn't understand it in depth, and I think my son has a better conceptual understanding. But the challenge is supporting them at home, when we don't maybe have access to that ourselves. Embarrassing as that
So
may be.
I'd be really interested,
Yeah.
to talk about how when is it convenient, and, we also have the two different the two different complexes, and, if we did something, let's say, for second grade parents, at Maple, would everybody come? And, those are the kinds of questions that we have.
And maybe grandparents.
Yeah, we also, I mean, I know it's a sad story, but we used to actually have a budget for these kind of programs, and we just don't anymore. And the teachers do so much, it's hard to ask them, it is hard to ask them to keep coming out at night.
And we have to recognize, too, we live in a largely working-class community, and most families are two parents working, if this, and it's, so trying to find a time where it's, yeah.
Well, one of the things that I've been talking with Kathy Lynch about is doing some little videos about things that are going on in the district, and this might be a perfect example of something that could be very useful for parents. You could do little TED Talks on different aspects of math.
Or who was that little penguin that had problems?
Yeah.
Oh, yeah, puzzle. Well, our fourth graders call him the perpetually puzzled.
Oh, well, now.
Get our vocabulary in there,
There
too.
you go. Math and language.
Lori?
So I just want to thank you for all that you do for our district, because this is incredible, and I thank you for coming to present this to us too. And I know you've been with us for so long. I can't imagine what you've gone through from when you first started in this to something like this. I'm
3
like,
sets of standards, yeah.
yeah.
Now, how was that for you?
That changes.
Well, it's really, I don't know quite how to answer that. It's interesting. I think that the Common Core standards are not perfect, but I think that they really do make us all focus on understanding. And as our international assessments have shown, we really do need more math literate population. I think there's a lot of math anxiety in our culture, and it really gets me kind of angry that it's like okay to say I suck at math. I mean, when I hear that, it just makes me shudder, because so many careers, I mean, just listening to you talk tonight before my presentation, listening to Andrew, are tied to math. And also there's some great research now that really shows that that everyone can learn math, that our brains actually grow and they reconnect, and the more we challenge them. And if you're interested, if you Google growth mindset, you'll see some really interesting TED Talks and some really interesting videos about that. It's growth mindset. And I think we need to send that message to kids, that you can all learn math. And it's not a question, like Einstein said. He said, don't worry about your problems with math. No one has more problems than I do. So everyone eventually is going to hit a wall, and it's really what you do when you hit that wall that will spell success or failure. So
I have to tell you that I went to one of your parent workshops about 11 years ago at the elementary school. It was a morning session, and that message that you just shared was on a handout, and I thought it was just revolutionary to me.
So positive.
The point made on it, and I still have this piece of paper. The kids have these school drawers, and every year I transfer. I don't throw it away. Every year I put it in the next drawer, because it's a constant reminder. I've quoted from that paper so many times over the years about your message about no one is necessarily good at math. No one is. It's all about perseverance, and it's the people that persevere that are successful in math. So it's all about perseverance. It's the matter of to keep at it. And so everyone hits a wall somewhere, and then it's those that can keep at it are the ones that are successful, and that it's all about perseverance. And I just thought that was such an amazing concept to really embrace, and I don't know, I just wanted you to know. It's stuck with me all these years. I've shared it a million
That
times,
is
and I've
wonderful.
shared it with other math teachers from other schools, because I just thought it was so helpful. Anyway,
And I just want to remind everyone that Joan Schaffer is one of our Pioneer Excellence in Teaching Award winners this year.
Obviously.
And you know why now, don't you?
Absolutely.
Joan's been a gifted teacher and has just been an amazing advocate for students and for mathematics in our district. Proud to have you here, Joan.
Thank you very much.